Hi there! Welcome to this learning activity video, and this is your teacher Marichu, and we have to learn math box for senior high school, and the objective, we have the learner solves exponential equations and inequalities. Let's start. For the exercises, we have the directions. Solve the exponential inequalities. Write your solution in your answer sheet. For number 1, we have 1/3 raised to x plus 1 is greater than 3 raised to negative 2. In this case, how do we solve exponential inequalities? And this time, how do we know that this is an exponential inequalities? Well, first, it has a base. In this case, on the left-hand side of the inequality, we have 1/3 as the base, and the exponent, x plus 1. On this side, we have 3 as the base and the exponent, negative 2. And it is an inequality because we have a greater than, or this is one of the inequality symbol, greater than. So this is an exponential inequality. Now, in order to solve an exponential inequality, we have to see to it that these two expressions here on the left side, the base, and the base of the right hand side must be equal. In this given example or exercises, they are not equal. Here we have 1/3 as the base, and here we have 3 as the base. So we need to manipulate mathematically in such a way that we can transform one of these to another's bases. In this case, common is 3, no? So we can raise, or we can express 1/3 as 3 raised to negative 1. Then, raise it to, we just copy the exponent x plus 1 and copy the greater than symbol, and we copy 3 raised to negative 2. Now, since they have already the same base, this exponent, negative 1 times quantity x plus 1, must be greater than negative 2. So we have it here. And in this case, we can solve for the value of x. Since we have here a negative x, we transpose it on the other side, it becomes x. And the negative 2 here, transpose it on the left-hand side, will become positive 2. And, well, let the constant negative 1 be here on its place. Then we have 2 minus 1 is greater than x. Well, this is 1. So it seems that 1, it is equal actually to 1 is greater than x. Or we can rewrite this as x less than 1. So the solution for this inequality is x less than 1. Let's check. Let's pick a number in this interval. So 1 is not included. All the x's in such a way that it's less than 1. Now, the most convenient, x is equal to 0. Let's substitute x equals 0 in the original exponential inequality. So we have here 1/3, raise it to x equals 0 plus 1, and then greater than 3 raised to negative 2. We put a question mark, signifying that we're not yet sure and we have to verify. Well, simplifying this, we have 1/3 raised to 1, or simply 1/3. Copy the greater than symbol, and 3 raised to negative 2 can be rewritten as 1 over 3 squared. And here, copy the question mark, we're not yet sure. And finally, we have 1/3. Well, this is greater than 1 over 3 squared, which is 9. Then this is a true statement. So therefore, our solution for this exponential inequality is x less than 1. Moving on to number 2 exercise. We have 2 raised to 3x plus 7 is less than 4 raised to 2x minus 1. Solution, we just copy, and then after that, we want to express 4. In this case, we have 4 raised to 2x minus 1. Express this 4 as a power of 2. That's 2 squared. Then, we just simply copy the exponent 2x minus 1. In this case, we just have to copy. Then here, copy 2, but distribute the 2 in the exponent. 2 times 2x, 4x. 2 times negative 1, it's negative 2. So we have now an expression or exponential inequality in such a way that they have the same base, 2, and with different exponents. So in this case, we have to write 3x plus 7 is less than 4x minus 2. Solving for x, we have to collect all the constants here for convenience. So this is 7 here, the 2 will be here, that's plus 2, that's 9. Then 4x is steady here, minus 3x, that becomes x. And finally, we can rewrite it as x greater than 9. So this is a solution. Now for the checking, let's take value of x to be equal to 10. Then substitute it to the original expression. We have 2 raised to 3 times 10 plus 7. That's 2 raised to 37. Is it less than 4 raised to 2 times 10 minus 1? So this is 4 raised to 19. But we have 4 can be rewritten as 2 squared. So we can have 2 raised to 2 times 19 or 38. So obviously 2 raised to 37 is less than 2 raised to 38. It's a true statement. Hence, x is greater than 9 is the solution to the given exponential inequality 2 raised to 3x plus 7 less than 4 raised to 2x minus 1. Moving on to number 3, we have 1/8 raised to x plus 3 is greater than 1 over 64 raised to 4x. Now 1/8 can be expressed as 8 raised to negative 1. We copy x plus 3 exponent greater than or equal to 1 over 64 is 8 raised to negative 2. Then copy the exponent. We multiply this exponent, so we have 8 raised to negative 8x. And on the left hand side, we have also to multiply negative 1 to quantity x plus 3. So this becomes now 8 raised to negative x minus 3. Now since they have the same base, we can now work on the exponents. So we have negative x minus 3 is greater than or equal to negative 8. Solving for the value of x or values of x, we transpose negative 8 on the left hand side, it becomes positive 8. Then we copy the minus x, and this constant, we transpose it on the other side. Then we have 8x minus x is 7x, then greater than or equal to 3. And we divide both sides of the inequality by a positive constant, in this case with 7, so that we can cancel out the 7 here and below. This becomes 1. This gives us x is greater than or equal to 3/7. Now let's check. Let's pick a value of 3/7 because it says here x is greater than or equal to 3/7. If we replace x equals 3/7, we expect that this will become equal. Okay, so we have 1/8 from the original expression raised to x plus 3 greater than or equal to 1 over 64 raised to 4x. Substitute the value for x, which in this case we have 3/7. Let's do that here. So this becomes 8 raised to negative 1 times 3 over 7 plus 3. Is this greater than or equal to 8 raised to negative 2 times 4 times x, or x in this case is 3/7. Adding the exponents here, we have 8 raised to 3/7 plus 3. Well, how many 7ths in 3? Imagine you have 3 cakes. Then each cake will be sliced to 7 parts. So how many slices are there? How many slices of 7 in the 3 cakes? So 3 times 7 is 21. So we have this 3 equals 21 over 7. Plus 3 sevenths, we have 24 over 7 times negative 1. We have negative 24 over 7. And this is equal also to, let's have the right hand side here, 4 times 3 sevenths, that becomes 12 sevenths times negative 2, that's negative 24 over 7. So this is a true statement. You can also substitute right away here, 1/8 raised to 3 over 7 plus 3. So this is 1/8 raised to 24 over 7. Now in this case, 1 over 64 is 1 over 8 squared. Well, you can try. You will end up with the same solution or equal symbol here. Now if we choose values of x in such a way that it's greater than 3 sevenths, say for example x equals 1, let's see here, 1/8 raised to 1 plus 3, that's 1/8 raised to 4. Is it greater than 1 over 64 raised to 4? Well, 1 over 8 squared here, then obviously we will have a negative exponent if we have here 1/8 as the base. In this case, it's 1 over 8 raised to 2 times 4 times 1. That's 8. So we have a true statement. Hence, our solution for this inequality is x must be greater than or equal to 3 sevenths. For number 4, enrichment activity, solve the following exponential inequalities and write your solution on your answer sheet. Let's start with number 1. 4 raised to x minus 2 less than or equal to 1. Solution, copy the expression, then it has to be that the expression on the left side has the same base as on the right side. Well, 1 in terms of a base 4 with exponent, so 4 raised to 0 is 1. So we can rewrite 1 as 4 raised to 0. Now we have the same base, so we can copy or we can write x minus 2 is less than or equal to 0. Solving for x, we have x is less than or equal to 2. Now for checking, let's have x equals 2. Going back to the original inequality, is 4 raised to 0 equal to 4 raised to 0? Of course, it's true. Now, if let's choose the value of x less than 2. In this case, x equals 1. So we have 1/4 is less than 1. Is it true? Yes, it's a true statement. So therefore, after the checking, we end up with the solution to this inequality or exponential inequality to be x is less than or equal to 2. Moving on to number 2, we have 5 raised to x minus 2 greater than 5. Well, we can equate or we can raise 5 raised to exponent 1 because that is equal to 5. Then, this will give us x minus 2 greater than 1. X is greater than 3. So, meaning we can choose values of x greater than 3. Like 3.1, 3.2, 3, and so on. But let's choose an integer x equals 4. So, substituting here, we have 5 squared greater than 5. It's true. Hence, x greater than 3 is the solution to the given exponential inequality 5 raised to x minus 2 greater than 5. Number 3, 2 raised to x minus 3 less than 1. Again, we have to express 1 as 2 raised to 0. So, copying, they have the same base. So, x minus 3 is less than 0. Solving for x, we have x is less than 3. Now, we choose value of x to be 2. Substitution, we have, is this equal or is this true? 2 raised to 2 minus 3, that's 2 raised to negative 1, or simply 1/2. And 1/2 is less than 1. It's true. Hence, x less than 3 is the solution to the given exponential inequality. For number 4, 2 raised to x minus 2 less than 1/2. We need to express 1/2 in an expression or exponential form in such a way that the base is 2, while 1/2 is actually equal to 2 raised to negative 1. So we have 2 raised to x minus 2 less than 1/2, which is 2 raised to negative 1. They have the same base, so we can take the exponent part, x minus 2 less than negative 1. And simplifying, we ended up with x less than 1. Checking, let's pick value for x equals 0. Then we have to substitute here. That's 2 raised to negative 2. Is it less than 1/2? Well, 1 over 2 squared. So this is 2 raised to negative 2. We put it down, so that is 1 over 2 squared. Is this less than 1/2? It's true. 1/4 is less than 1/2. A true statement. Hence, x less than 1 is the solution to the given inequality, 2 raised to x minus 2 less than 1/2. Number 5, 1/2 raised to x minus 4 greater than or equal to 8. Well, we copy 1/2 can be rewritten as 2 raised to negative 1. Copy the exponent x minus 4. And 8 can be written as 2 cubed. So, simplifying, we have negative 1 times x, that's negative x. Negative 1 times negative 4, that's plus 4. And we have 2 cubed, greater than or equal to. Then, they have the same base. We just have to copy the exponents, negative x plus 4. And copy the greater than or equal to symbol. And then we have to copy 3. Simplifying, we have x here is less than or equal to 4 minus 3, which is 1. Now, let's take x equals 1. Substitute with the original expression. We have 1 minus 4, 1/2 raised to negative 3. Is it greater than or equal to 8? Here, we have 1/2 can be rewritten as 2 raised to negative 1 times negative 3. Is it greater than or equal to 8? In this case, 2 cubed equals 8. It's true. Now, let's choose values of x less than 1. The most convenient is x equals 0. Then, substitute with the original expression. We have here 1/2 raised to negative 4. Is greater than or equal to 8? Question mark. Well, here we have 2 raised to 4. So, is this greater than 8? Well, 2 raised to 4 is 16. It's greater than 8, and it's true. So, therefore, hence, x less than or equal to 1 is the solution to the given exponential inequality 1/2 raised to x minus 4 greater than or equal to 8. This concludes our learning activity video, and please like, share, and subscribe this video, and please always stay happy, healthy, and safe. God bless us!